All right, welcome to Unit 5 on sampling distributions. This is really a pivotal unit that kind of connects everything we've learned so far to everything that's to come in the future. So it's a pretty important unit and one that you really need to understand the theory behind. So this is a video over topic 5.1, which is called Why is my sample not like yours? So the big ideas that we need to understand before we can even process what's in this unit is these two big ideas. Samples create statistics. Any numerical description of a sample is called a statistic. From a sample, you could find the center, like the mean or the median. You could find a numerical description of how that data spreads. For example, standard deviation, the range, the IQR. You could find a proportion if you're talking about categorical data and you want to find the proportion of people that said yes, the proportion of people that eat chocolate ice cream, something like that. You could find a proportion. Even individual values from a sample are also statistics, like the min, the max, Q1, Q3. Those individual numerical values are also known as statistics. So anything that comes from a sample is a statistic. Easy to remember, sample begins with S, and so does statistic. Now, the second big idea is that statistics will vary from one sample to another. We call this natural variation sampling variation or sampling variability, or you might even hear some people call it sampling error. This extra variation that exists between samples is completely natural and unavoidable. For example, if I collect a sample of 30 giraffes and the average height is 8.1 feet, somebody else might select a different sample of 30 giraffes and get an average of 9.2 feet. The fact that my sample has a different mean than somebody else's sample is nothing wrong. It's not an error. It's just natural sampling variation that occurs when we sample. So not only are the giraffes in our sample going to vary, but also the sample, my sample compared to somebody else's sample, are also going to vary. So this natural variation that exists between samples is called sampling variation, sampling variability, or again, you will see some people call it sampling error. You cannot get rid of this variability. However, it can be lessened with bigger sample sizes. If we look at sample sizes of 100 giraffes, then my sample is probably going to be closer to somebody else's sample because there's more giraffes in the sample, and more giraffes in a sample will give me a better mean average closer to the truth. All right, so the idea, if you understand those two big concepts, now we can understand that we live in a very crazy world. There are so many questions and thoughts that scientists, doctors, engineers, teachers, psychiatrists, politicians, etc., that they want to know the answer to. And oftentimes the only way we could get those answers is to look at a sample of people, animals, or objects. So really, this class is vital to any field that you go into, because anytime you have a question that you want to find an answer to, it starts with finding a sample. But keep in mind, there's one thing that is for certain, is that those samples are going to vary. So what are some questions about the world around you that you want to know the answer to? So this is kind of a blank slate because I want you guys to start thinking about something that you really want to know. For example, it could be something simple like, hey, what is the average height of a giraffe? Or what proportion of people in Pennsylvania are Democrat, right? To answer those questions, you need to start with samples. It could be a little bit more complicated, like does drinking a protein shake lead to more muscle mass? Maybe I'm trying to, get bigger muscles and I want to know, does drinking a protein shake every day help that? That's a little bit more complicated, but again, you can't answer that question, excuse me, until you take a look at a sample. All right, so here are some other things that, I think about on a daily basis. What proportion of high school students study? What proportion of people eat ice cream every night like me? Do cats live longer than dogs? Does a larger proportion of girls take AP classes than boys? What is the mean number of credits a science major graduates college with? What is the median house price in my city? What is the standard deviation for the weight of dogs? Again, all of these questions can only be answered by taking a sample, or maybe you need multiple samples. Now, all of this leads us to the start of statistical inference, which is also known as forecasting, right? Forecasting is this idea that we don't know what the future is going to be, but we're trying to make a prediction about it. All right. And what we could do is take the information from a sample and we could use that information to make conclusions about the wider population that the sample was taken from. So we must be very clear when a number represents a sample or whether a number represents a population. So we do use different symbols for this. We've shown you this already once this year. It's important that you see it again. For example, when you're talking about the mean of a sample, we call that a sample mean, and we use the symbol X bar. If you're talking about the mean of an entire population, we call that mu. The the standard deviation of a sample, how that one sample deviates, is known as S. The standard deviation of an entire population is known as sigma. If you're looking at categorical data and you're counting how many people said yes, or how many people are Democrat, or how many people like chocolate, then if it's a sample, you're going to call that a sample proportion, which we call that P hat. And if there is no hat, then that is a population proportion. That's something that's true for the entire population. And again, forecasting is this idea of using your sample mean as an accurate reflection or an accurate forecast of what that population mean could be. Or the same thing for a sample proportion. We could take that sample proportion and hopefully we could accurately forecast what might be true for the entire population. So we're always using our sample data to hopefully forecast the population data. But I need you to understand, a sample collected to try to answer any of these questions will vary from any other possible sample that could have also been collected. This is this idea of sampling variability. For example, maybe I have a sample of 450 high school students and it found that 41% study daily. But any other sample of 450 students could have been different. Could have been 42%, it could have been 38%, could have been 50%. I don't know. All I know is my one sample, but I have to know that it could vary from other samples of the same size. A second example could be my sample of 175 science majors in college found that the mean number of credits they graduated with was 125. But again, any other sample of 175 students could have been different. Could have been 126, could have been 124, could have been 130. Who knows? But I have to understand that my sample is my sample, and it's definitely going to vary from other samples of the same size. So the real task of this entire unit is understanding how samples vary so that I can determine if my sample is a good forecast or not. And this is really going to be the entire focus of Unit 5. Understanding how samples vary. When you leave this unit in the next couple weeks, you need to be able to say, I totally understand how samples vary. And the cool part by the end of this unit is that how samples vary can actually be calculated in a very, very simple way. And it's not that difficult once we learn everything there is to learn. So that's going to be the next task. So good luck. Be ready. It's actually a pretty fun chapter, and it sets us up for everything we're going to do the rest of the year.